So, hi everyone. Today we are back with a question from CSIR NET, which was held on 26 November 2020, and the subject is again integral equation, and which is from the part C section, and the question is multiple select, as we know. Okay, so let's see what the question is. For the Fredholm integral equation, we are given a Fredholm integral equation, which is homogeneous Fredholm integral equation. And then we have to choose the two statements from the given options. It says that it has a non-trivial solution satisfying this condition, or only the trivial solution satisfies this condition. It has non-trivial solution for all lambda non-zero, and it is non-trivial solutions only if lambda equals to 2 by e square minus 1 and e power t y of t non-zero, integration from 0 to 1. Okay, so we have to choose the two statements. So first of all, we have the Fredholm integral equation, which is homogeneous. So we'll use the method reduction to a system of algebraic equations, isn't it? Like we use the matrix method in short form, we can say that. So first we'll just see the method and then we'll just solve the question. Okay, so we are given with the integral equation that is nothing but y of s equals to lambda 0 to 1 e power s into e power t y of t dt. Okay, so we'll use just a simple method. We just reduction to system of linear algebraic equations, homogeneous algebraic equations. Okay, so we'll just use this method in which we do like lambda, and then which is the function, this variable s, we'll just take it outside, and then we'll just put c1, an arbitrary constant whose value is nothing but e power t y of t dt, 0 to 1. Okay, so what we do in that method is we just put the independent variable, we can say, not an independent variable, but we can say like the integration with respect to that variable. We just put that function as c1 and or c2, some arbitrary constant, and then we'll just solve that equation, nothing else. Then we'll just find out the value of c1, and then we'll just get our solution. Okay, so c1 in that case is e power t, and what is y of t? We'll just use this one. This is y of s. So what is y of t? So y of t will be lambda e power t c1 dt integration 0 to 1. Sorry, this is under integration sign. So 0 to 1 e power t this. Okay, so this is nothing but lambda e power 2t c1 dt 0 to 1. Okay, so we'll just solve this integration and then we'll just putting in this one, and then we'll getting our solution. Okay, so we are getting here c1 equals to lambda 0 to 1 e power 2t c1 dt. I'm just taking outside c1 because that is constant. So e power 2t by 2 integration is this one c1. So this is c1 equals to lambda c1, and then we're just putting this e square by 2 minus 1. This is okay. So we are just finding out the value of c1 here. So c1 is nothing but 1 minus lambda e square minus 2 e square minus 1 by 2. Okay, so this is equals to 0. Then they are asking the conditions on this particular value. Okay, so we have our solution as y of s is equals to lambda e power s c1. Okay, so they are asking about this conditions in these conditions. Okay, so in the first option they are saying that it has a non-trivial solution satisfying this. Okay, so this is nothing but our c1, isn't it? This is nothing but our c1. This is our c1, na? We have our c1 as e power t y of t dt 0 to 1. Okay, so they are saying that non-trivial solution will satisfy this condition, but this is nothing but our c1. If c1 is 0, So in that case, our solution is 0 because C1 is 0, so y of s is 0. So it can't be true because whenever this equality will be satisfied, this solution will be trivial. It will not be non-trivial. Okay, so this is wrong. Okay, so the second one says only the trivial solution satisfies this. That we have find out that whenever this C1, this quantity is 0, so this C1, this RHS side will be 0, so our solution will be 0, will be trivial solution. So only trivial solution will satisfy this, so this is true. Okay, C option says it has non-trivial solution for all lambda non-zero. But we can see that whenever C1 is 0, it doesn't depend on this solution. So this is wrong. And the fourth one says it has non-trivial solutions only if this lambda equals to 2 by e square minus 1 and e power t y of t dt is non-zero. Okay, so this is nothing but our C1. So they are saying whenever C1 is 0, when C1 is 0, so we'll be getting our solution as trivial solution. Trivial solution. Trivial solution. Whenever we have C1 non-zero, so in that case our solution will not be trivial. No, C1 is non-zero. Okay, so whenever this quantity is, if it is 0, so if C1 is non-zero, this quantity should be 0. What is that quantity? Is lambda e square minus 1 by 2 and equals to 0. So this quantity is 0 now. So this is nothing but 1 equals to lambda e square minus 1 by 2, and this will imply lambda equals to 2 by e square minus 1. Okay, so in that case we are getting trivial solution. Whenever we are taking C1 is non-zero, so we are getting lambda equals to 2 by e square minus 1. So in this particular condition we will be getting our non-trivial solution. Okay, so in that case it will have non-trivial solutions only if this lambda equals to 2 by e square minus 1 and e power t y of t is non-zero. Like C1 is non-zero. Whenever C1 is non-zero, it will have non-trivial solutions first of all. And the second one is when we take C1 as non-zero, so we are getting lambda as 2 by e square minus 1. So for lambda equals to 2 by e square minus 1, we will be getting non-trivial solution. In that case, our D options will be true. Okay, so in that question, B and D were the right answers and A and C were the wrong ones. Okay, so this was a question from integral equation which was, I think, very easy. For multiple select even, we are getting 4.75 marks. That I think that was a free question, like a treat kind of question. That was very easy question. Okay, so this is the Fredholm integral equation and the question is done. Thank you.